30 years ago, the world's longest-running evolution experiment began when scientist Richard Lenski seeded 12 identical flasks with E. coli bacteria. Every subsequent day, someone in the lab has transferred a sample of each flask into a new flask, and every 75 days a sample is frozen, acting like an evolutionary time capsule. After 3 decades, the experiment has rolled through more than 67,000 generations of E. coli, which the researchers note is equivalent to over 1 million years of human evolution. Our study, published in Nature, provides a high-resolution view of the molecular details of adaptation over substantial evolutionary timescales, says study co-lead author Dr. Mike McDonald. The insights we provide into the rate, repeatability, and molecular basis of adaptation will contribute to a better understanding of these evolutionary processes and challenges. One of the most compelling results of the experiment has been the observation that the bacteria has seemingly been constantly evolving despite the static and unchanging simplicity of its environment. In our study, we found that even though the E. coli populations in our experiment have been evolving in a very simple environment for a long time, they are still adapting to their environment, says Dr. McDonald. In other words, the fit get fitter. But the established theory tells us that adaptation should have stopped by now, since there should be a fitness peak that the E. coli should have reached by now, and our work shows that this is not the case. The researchers hypothesize that the constantly evolving E. coli is dynamically changing the environment it is growing in. This results in a kind of feedback loop where the bacteria evolve and change its environment, stimulating yet another stage of evolution. Thus, despite a static environment, the population should never stop evolving. Unsurprisingly, all 12 bacterial cultures have improved in competitive fitness over the 30-year evolution. They all grow faster and have bigger cells than at the start of the experiment, but each culture has developed its own unique pathway to better fitness. Perhaps the most novel evolutionary tweak arose in one of the cultures at about 20,000 generations. A culture evolved the ability to eat citrate in addition to glucose, a feature not previously seen in E. coli bacteria. McDonald sees this ongoing experiment in evolution as offering a vital understanding into how we can better predict the adaptive changes that result from evolutionary processes. Cancer is an evolving group of cells within your body. Antibiotic resistance is the result of bacteria adapting to the use of antibiotics, and climate change is forcing whole ecosystems to adapt or die, says Dr. McDonald. There are no plans to end the E. coli experiment anytime soon, with scientists continuing to reset the flasks every day and observe the ongoing evolution of the Lenski bacteria. The latest study was published in the journal Nature. View Gallery 2 images.